configuration of ions. We have two types of ions. We have the anion, which is the negative ion. So for atom X, we have anion X minus. How X minus is obtained from X? X plus 1 electron gives X minus. So to deduce the electronic configuration of X minus, we have to write the electronic configuration of X, then to add 1 electron. So the electron is added to the atom according to rules, according to Aufbau rule. If we want to add electron, this electron is added to the lowest energy unoccupied orbital. For example, suppose you have sulfur and we want to write the electronic configuration of S2 minus. So the sulfur should gain 2 electrons. S plus 2 electrons give S2 minus. So on the electronic configuration of sulfur 16, we have to add 2 electrons. We can add these 2 electrons. We have 3s, 3p, and we have a 3d vacant. I cannot put these 2 electrons in the vacant 3d, since the 3p can receive 2 electrons. So 3p4 receive the 2 electrons and become 3p6. If, for example, the orbital p is completely filled, so now you can fill in the orbital 3d, which is vacant. Okay? So the electron is added to the lowest unoccupied orbital. The lowest unoccupied orbital is 3p4. Someone will say that 3s is of lower energy. This is true, but 3s is completely filled. It cannot receive. So 3p4 is the lowest unoccupied orbital. In case of phosphorus, we have electronic configuration that ends by 3s to 3p3. So p can receive maximum 3 other electrons. It becomes 3p6, 4p3 minus. So in the anion, we write the electronic configuration of the atom. We add electrons, and the electrons are added to the lowest energy unoccupied orbital. And pay attention for the term unoccupied. The cation is positive ion. So the cation is obtained from the atom by subtracting electrons. X minus electron give X plus. So we have to remove 1 electron from X, for example. When we remove electron, we remove from the electrons that are the less attracted by the nucleus. So we remove the electrons from the valence shell. For example, suppose we want the electronic configuration of vanadium 2. For vanadium, we have abbreviated electronic configuration, argon 4s2 3d3. What is the valence shell? The valence shell is 4. And on the valence shell, we have 2 electrons. So the 2 electrons of 4s are the less attracted by the nucleus, because these 2 electrons are the most distant from the nucleus. So if we want to remove the electrons, we could not remove the 3 electrons of 3d. We have to remove of the electrons of the valence. So we remove the electrons of 4s. And the electronic configuration of vanadium 2 is argon 4s0 3d3, or simply we can write it as argon 3d3. Periodic properties of the elements. So we have to treat or to explain the periodic table. The periodic table is a representation, man-made. It's not a true in the science of the atom. It's a representation. Suppose you have on your desk 3 pens, okay? You can distribute or arrange it in a way to use, for example, the green or the blue or the red. So this is your representation. Why you did this representation? In order to make easier the use of these colors. So the periodic table is an arrangement of atoms, of elements. And this arrangement make easier the reading of the properties of these elements. So we have some information from the periodic table. When one looks at a periodic table, there are many letters and numbers. And these letters and numbers help to identify the elements and to know or to know their characteristics. If we understand these letters and numbers, we can better understand the properties of the element. The periodic table was organized over the years to provide scientists information about the different elements. And pay attention that the periodic table is man-made. It's not a real effect in the atom science. It's a man-made. So the elements are placed in order, such as atomic mass or atomic number or atomic size and other things. To know that the first periodic table was discovered or was organized by Mendeleev over 130 years ago. Mendeleev observed that some elements have the same chemical properties. For example, if we take sodium in water, we observe that the reaction is highly exothermic. We repeat the same experiment with potassium. We observe that this reaction behaves by the same way, and this reaction is exothermic. So we say that sodium and potassium have the same chemical reactivity. So Mendeleev put these elements in the same column. So elements of the same column have the same or similar chemical properties. The periodic table, the modern periodic table, is composed of 7 rows and 18 columns. We have block S. What is the meaning of block S? Their electronic configuration ends by S. We have a block P from column 13 to column 18. Their electronic configuration ends by P. And we have a block D. The electronic configuration ends by D. And we have a block F. The electronic configuration ends by F. We have 3 types of elements. We have elements, metal, we have non-metals, and we have metalloids, which are between the metal and non-metal. How to know the property of the element if metal, non-metal, or metalloid? We construct what we say the boron ladder. The boron ladder. From boron, we construct the red ladder. The elements below are metals. The elements above are non-metals. The elements on the ladder are called metalloid. Boron, silicon, germanium, and all others are metalloids. Their properties is between the metal and the non-metals. The periodic table is composed of block S, block P, block D, and block F. And in the same block, we have families. For example, in block S, we have column 1 or group 1, which is the alkali metals except hydrogen. Group 2 or column 2 ends by S2 are called the alkali earth metals. Column 13 or group 3, the column start by boron. This is the group of boron. Column 14 or group 4 start by carbon. This is the group of carbon. Column 15 or group 5 starts by nitrogen. This is the group of nitrogen. Column 16 or group 6 starts by oxygen. This is the group of oxygen, or known as chalcogens. CHALCOGEN, the group of oxygen or the chalcogens. Group 7 in purple, this is the halogen. And group 8 or column 18 in green, this is the noble gas. The elements that end by D are called the transition metals, and the elements that ends by F are called the lanthanides or the actinides. So we have to know that we have 4 blocks: S, block S, block P, block D, block F. In the block S, we have 2 families: alkali metal, alkali earth metals. In the block P, we have 6 families: the group of boron, the group of carbon, the group of nitrogen, the group of oxygen or chalcogens, the halogens, and the noble gas. And in block F, we have 2 families: the lanthanides and the actinides. We have to keep in mind some important properties. The period of the element, the period are the element in the same row. The group are the element in the same column. So the period of element relates the number of shells of an atom of the given element. Suppose an element is in line 4, 1, 2, 3, 4. So I say that it has 4 shells, or it's in line 4 or in period 4. The group is the number, the group for block S and the block P only. For D, they are called transition metals, and for F, actinides or lanthanides. So we talk about the notation group only for block S and the block P. The group is the number of electrons on the valence shell. Suppose we have boron. Boron has Z equal 5. 1s2, 2s2, 2p1. So the valence shell is 2. And on the valence shell, we have 2 electrons, 2s, and 1 electron, p. So the boron, the boron is in group 3. The carbon ends by s2p2 is in group 4. The nitrogen ends by s2p3 is in group 5. The oxygen ends by s2p4 is in group 6. The fluorine ends by s2p5, so is in group 7. And group 8 ends by s2p6. What is the valency of an element? The valency is the number of electrons it can accept or donate by the element. Suppose oxygen ends by s2p4. It should receive 2 electrons. So the oxygen has valency 2. The nitrogen ends by p3. So it can receive 3 more electrons. The nitrogen has valency 3. Consider sodium in group 1. Sodium ends by s1. So it has to lose this electron. So it can release 1 electron. So the valency of group 1 is 1. Valency of group 1 is 1. Valency of group 2 is 2. Valency of group 3 is 3. Valency of group 4 is 4. Valency of group 5 is 3. Valency of group 6 is 2. Valency of group 7 is 1. And the valency of group 8 is 0. The number of elements in the period is calculated by 2n squared. For example, in period 1, we have 2 elements, helium, and we have hydrogen and helium. In level 2, 2 square 4 times 2, 8. We have 8 in level 2. 1, 2, 3, 4, 5, 6, 7, 8. In level 3, for n equal 3, 3 to the power 2, 9. 9 times 2, 18. 1, 1, 2, 3, 2, 10, 12, and 6, 18. The early versions of the periodic table was constructed by Mendeleev and we now know in the modern periodic table that the periodic properties are due to the electronic structure of the atom, especially of the valence electrons. The importance of the periodic table, it makes easier the reading of the properties of elements, and we will study the following properties: the atomic size, the ionization energy, and the electron affinity. So in this figure, we have Al, Zn, En, In, Sn, Cd, Ga. We put this element in the periodic table. When we know their places in the periodic table, we can compare qualitatively and not quantitatively. Qualitative analysis, we can compare their atomic size, their ionization energies, and their electron affinity.